Cool, so next up we're going to do our second fixing then for our electrics. So we've already done our first fixing at this point, and we've put all the wiring around the walls and everywhere. Our second fixing is the point where we're actually going to connect everything together. So here I'm going to show you how to install your lights, going to show you how to install USB sockets, mains inlet as well, and how we're going to go about and fuse all of this and make it safe to use. And I'm also, even though I'm not going to install it on this van, I'm going to talk a little bit about installing an inverter and a solar panel as well, in case you guys want to do that.
Sitting back on the road, back on the road, and back on the road, back on the road, steady as I go.
Hi folks, so thank you for stopping by. If you would like to learn how to build a camper van like this yourself, then please check out my other YouTube videos. So if you guys have found these videos helpful, you can help me out in a big way by picking up a copy of my first ever album that my brother and I recorded in Nashville late last year. Any proceeds will go to future recording projects, as well as taking the band on tour and hopefully promoting it. I'll leave a link in the description and talk a little bit more about it at the end of this video. We're going to be using one of these for this project. It's a Sargent EC160, and it has all your fuses for the 12-volt system installed in it, and it also has some circuit breakers as well for your mains system, and also a few buttons here so you can isolate things like the lights and the water pump, etc. if you've got one of those. And at the back as well, we also have our cable which runs to our mains inlet, just on the outside here, which allows us to then hook up to a campsite. Next up then, I want to go ahead and start connecting some of our sockets. So essentially these are going to sit inside there. First of all, I'm going to be using one of these double USB sockets. I think this will be really handy inside the van for charging things like your phone without draining masses of power. So as you can see on here, these are going to take two Spade Crimps. So these are what the Spade Crimps look like. I've got a terminal assortment here. So you've got tons of different items in here. You can get little ring crimps, you've got, like I say, the Spade Crimps, got some butt crimps which are just like straight crimps, you've got various bits and bobs anyway, but for these we want to use a Spade Crimp. This is basically our wire is going to feed into the end here, and again crimping it, we're going to squash this onto the wire itself, and then that is simply just going to slide onto the end of there, and that's how we make our connection on these USB sockets. So it's really straightforward actually, and it says plus and minus on the back of these sockets. I think these are made by CBE, by the way. So yeah, let's go ahead and do that. So first up then, we're going to want to go ahead and strip the wire. Here we have a fairly inexpensive crimping tool. You can pick these up for £3 or £4 on eBay. On there they have the crimping side of things here, and also some wire strippers at the very end. So along here on the wire stripper section, it has the different sizes of different wires. So you need to place your wire into the corresponding size. So if our wire is 1.5mm, for example, we're going to place it into the 1.5mm section. So I'm going to place that in there. So I'm going about a centimetre from the top, and then you just simply lock down and then you can pull away. Great, so now that we've stripped back the insulation on our wire, we can check the copper strands are intact, which they are. We're going to go ahead and add our Spade Terminals. The ones we're going to be using for this are the fully insulated versions, so it looks exactly the same as this, so it has insulation all the way to the end. This is just to ensure that when we attach our wires to the end of our USB socket, that is fully protected. So there's 3 different sizes of Spade Terminals. You tend to get them in a yellow, blue and a red colour, red being the smaller ones, and they are going to fit our 1.5mm cable that we're using here today. So I'm going to show you how to crimp them. We're going to take our red Spade Terminal and I'm going to place it within the teeth here that correspond with that red dot to our red Spade Terminal. I'm just going to close it up so it holds it in place, but as you can see, there's not a lot of our Spade Terminal sticking out from this end, and we don't want to be clamping down on the actual spade part of our terminal. So we're just literally on that cylindrical part, And then you can twist the copper strands on the end of your wire to make sure that they're nice and neat and that they'll feed through. We're going to push that all the way through, and then once we've done that and we hold that in place, you can then start to clamp down using the ratchet crimping tool. Alright, we can give that a little tug and we can feel that that isn't going anywhere. So you can use one of these more inexpensive crimping tools, but you have to judge manually when to stop forcing the crimp together. So you need to give it a reasonable amount of force, like a pretty reasonable amount, but you don't want to squash it so much that you're actually going to damage the copper wires. So you're going to have to best judge that for yourself. So as we did before with our USB socket cables here, I'm just going to go ahead and strip about 1 centimetre of the insulation of each individual wire. So once again, once you finish stripping the insulation, just go around each of these wires. It's really important that you check that all the copper strands are intact. For our 230 volts, we've got a back box here. So our back box is going to literally sit behind our plug socket. This literally just clamps into place, like so. This is just going to give some protection to the wires. So we're going to feed this back box on right now. Actually, there's a couple of screws on this bottom section here which we're going to release with a screwdriver. We can then feed our mains cable through that hole at the bottom there. So get the whole thing through and the insulation surrounding all 3 cables, and I would just pop this to one side, hopefully somewhere where it will stay. So when you get your USB socket, it's going to look a little something like this. So there's going to be a face that you can feed the USB socket through, like so, and then you'll get a plastic ring like this that you can then screw down along these plastic threads on the USB socket, and this will hold it in place to the face. As you get towards the end, it'll be a good idea just to check that your USB socket is straight, and then just tighten it down by hand. Now we've got that in place, we can go ahead and feed our cables in. So on the back of here is a positive and a negative sign. So we're going to run the positive through the red cable to help us differentiate the two, and the black through the negative, of course. So that USB socket is all hooked up. We just need to go and hook it up at the power management unit later. So as you can see on our main socket, we have a earth in the middle. We've got a live, which is going to be the brown wire. Our earth is going to be the green and yellow one, and the blue one is going to be our neutral, which sits in there. So what you probably want to do first is just unscrew these terminals. There's the 3 of them here, and then you're just going to want to feed these cables through. So my earth wire is going to sit in there. I'm just going to feed it through like so, and then we'll take a screwdriver and just tighten it down onto those copper strands. And do the same for the live and the neutral. This back box will clip over the top. So what I'm going to do now is just place the little bar across it and the screws. So don't do it too tight, but putting this on it just helps keep the wires in place. Put that into place in a sec. So just very quickly whilst I think of it, make sure that when you're screwing down these terminals, that you are in fact screwing down on the copper strands and not on the insulation of the wire, otherwise you're not going to make good contact. That's what the other end looks like. And when you're trying to find out which wire goes into where, you can look out for the signs. As you can see, there's an L here for live, N for neutral, and the middle one is the earth with that signal there. Now they're all hooked up, we need to go and attach our face frame and attach this to our kitchen unit. There's 2 parts to the face frame. So the socket itself will actually clip in to this black part, he says, like that, and same with the other socket, and you will screw this down to the kitchen unit. That's what's going to hold it in place, and then this extra part here simply just clips on. So we're going to push our cabling back through here. If you have tons of excess cable, it's not a problem. We'll pull it through the conduit in just a little bit. I'm going to attempt to clip these into place, push them from the back if you need to, and same with the USB socket. And there's 2 points here where we can screw. And then we can go ahead, like I say, just clip on this outer section here. As you can see, that just snaps into place. Now you could be a bit creative with that, and you could put something else on there for sure. I've seen people make their own copper outer edges, and that looks really cool, so you can experiment with that if you want to. Essentially, that is all done. It's just a case of hooking it up to our power management unit a little bit later on. So next I'm going to show you how the 12-volt socket is going to work. You can see we've got a positive Spade terminal coming off of here and a negative one down this side of the socket. So as before, so on the back of here we have a positive and a negative sign. So we're going to put our black cable onto the negative Spade terminal there, and then the positives on this one. Okay, I'm going to be using one of these back boxes. It's going to fit on here. I'll feed these 2 wires through. I'm going to feed the red one through that slot, and the black one through there. So can connect these up. Again, we have a positive and a negative sign on the back of our socket, so the red's going on to the positive. You might have to wriggle this on. Negative on there. I'm going to feed some of this excess cable through. Just removing a little bit more of this insulation just to make sure I can get this back box in. So a couple of screws. And these screws are just 3mm thick. Okay, so there we have our socket in. So now here we are about to install the lights, and as you can see I've tied these around like this to prevent them from being pulled back through our hole and then losing the wires. So what you can do at this point is actually unravel these very carefully, just making sure that you do not accidentally pull them back through. It's okay to have a bit of excess, but we obviously don't want loads up there, otherwise it's going to be difficult for us to push the light up into the hole. Great. So again, as we did before with our USB and 12-volt socket, you just need to strip 1 centimetre of insulation. What we are going to do now, that we stripped the wire off the insulation, we checked that all the copper strands are intact, we're going to take our 2 positive wires, place them together like so, and I'm going to just join them together. And we'll do the same with the 2 black cables. Now we're going to take our crimp, and because we've just twisted 2 wires together, this is now going to be fairly thick. So instead of using a red Spade terminal, which will be appropriate for a single wire of this size, we're going for a blue one. Then go ahead and put it through, and then taking the corresponding blue part of the teeth here, we can then go ahead and crimp this. Do the same with our black one now. Now that we have our 2 crimp terminals on there, we can go ahead and connect up our light. So in this case, the red will be our positive. I don't know that, simply just because it's red. So it's just a case of sliding those on with these Spade Terminals, and this one will connect up to the other side. I'm going to wrap some electrical tape around these just to ensure that they're well insulated. As you can see, we do have some exposed metal here, so we don't want that touching the metal on the van at all. So unlike our first light and any lights that you may have after that one, on your very last light you're just going to have one wire coming in and one wire coming out, so one on the positive and one on the negative. So I've just put some Spade Terminals in this again, and we're going to go ahead and cover it up with some electrical tape. So one thing we need to do before we go ahead and pop these lights into place is just check that there is insulation above there. If there isn't, then moisture within the air in the camper is going to come into contact with the metal on our ceiling here, and it's going to condense eventually and then just drip onto the top of your light, and then it will cause your light to fault. So we just want to go ahead with some expanding foam if you do have any gaps here in your insulation, and just really make sure that it's all covered. So once you've given enough time for the foam to finish expanding and it's set, you can then go ahead and push the lights up into the recess. It's just a few clips on either side and it will just literally pop into place. Next up then, I want to go ahead and install the mains inlet. Now on these systems there's an orange cable like this that's coming out. It's already pre-wired into the system, and it's literally just a case of hooking these three wires here up into the mains inlet itself. So we'll go ahead and do that next. So just go ahead and unscrew the mains inlet now. Once you've removed that from the side of your van, there's a screw in the back here that you can undo with a screwdriver. Put that somewhere safe, and you should be able to take this back panel off, and that will reveal where you need to be putting your wires very shortly. So we're now going to go ahead and feed our orange mains inlet cable here through the hole that we had created previously, and it should come around to the other side where I can then feed it all the way out. There we have it. There we go, that will give me enough to go ahead and put it on. So as with our main socket then, you'll see some signs on here to indicate where you need to put the live, the neutral and the earth. So our live is here, it's going to fit through that little hole there, and we can adjust it with a screw to hold the wire in place. There's the neutral on this side and the earth is just there in the centre. So before we go ahead and feed all the wires through, I'm going to take that little back box bit that we removed, and I'm just going to take out this little circle here using a sharp blade. So I've just removed that little circle there, and I'm going to feed the wires through like so. And now we can go ahead and feed the wires through. Okay, so that's just holding that in place. Just don't tighten it so much that it's going to break feed insulation. But right, now we can replace this back box into here. Just clip it in, and then replace that little screw as well on the back. Just apply a little bit of insulation tape around there just to make sure it doesn't rub on that hole. Okay, and now we can just simply push this back through. So once you've got your back plate on, we can go ahead and then feed this back through like so, and it's just simply a case of then putting those screws back on again. So I just want to show you this quickly. This is a wiring diagram that I took from Sargent, who are the manufacturers of the power management unit that we're using. Now previously I showed you how to wire up the split charge relay system, and we were taking a positive from the positive terminal here on the vehicle battery into a fuse, and we're going from the fuse into the voltage sensing relay, then we were going from there into another fuse which was then feeding to the positive on our leisure battery. Now here, alternatively, what we're actually going to be doing, because we have our power management unit, is we're going to be taking the positive terminal here on the starter battery into a fuse, our fuse to the voltage sensing relay, so that is all as before. But then we're going to be taking our cable then, instead of going to another fuse, we're actually going to be going from the relay into the power management unit itself. Now there's a little split charge terminal here at terminal 10, so we're going to feed that cable into terminal 10, and then eventually that's going to feed back round to our leisure battery, as we have this cable here coming from the power management unit onto the positive on our leisure battery. Now the reason that we're doing this is because we are then going to wire that terminal 10 to terminal 9 here, and that basically is a switch at terminal 9 that will isolate all of our electrical components when we start driving along. Basically what will happen is our vehicle battery will spike in voltage when the alternator starts running. Because the engine's running, the alternator will run, it will spike the voltage on the vehicle battery. That will send off the voltage sensing relay. So once that's switched itself on, it's going to send power to our split charge terminal, and then the power management unit is then going to send that to our EMC here, and it's going to be aware that the voltage is spiked, and it's going to know that the engine is running, therefore it is going to know to switch off these terminals here. So it's going to switch off terminal 6, 7 and 8, not terminal 5 interestingly. So if you have something like a fridge and you want that to be running even when the vehicle is in motion, you can wire that up to either terminal 5 here or terminals 11 and 12. But anything that's wired into terminal 6, 7 and 8 will now automatically switch off while the vehicle is in transit. So for both the cables that are coming from the leisure battery and the vehicle battery to the power management unit are going to be wired slightly differently now. So we're going to be coming out on the positive terminal of both with a 15 amp fuse, and then that's going to be going into our power management unit. So to do that, we have a 15 amp inline fuse that looks like this. You'll get a fuse hopefully like that you can just pop into place like so. That will just slot in. And then to connect these two pieces of cabling, Sargent recommend using 4mm cable for this, so that's what we're going to do. We're going to actually use a straight crimp like this one here. I've actually got one here on the end, so you'll literally just slot that on there, and then we'll slot the other side on, and then we'll just crimp the two together. Then don't forget to tape the ends with electrical tape as well, just to ensure that they're going to be protected. Cool, so we're getting there with the electrics now. We're at the point where we can actually start plugging things into the back of our power management unit. So hopefully there's enough light that you can see that, but this basically just has some terminals that you can screw the wires into. So if I give you an example, with our 12 volt socket here, so this was for the fridge, I've just stripped about a centimetre of the insulation off, as I showed you before. Then you can twist the ends, and you can open up the terminal first by using a flathead screwdriver, and then you can just feed it in as and where you need to. Now it is labelled on the back, but you can also get one of these wiring diagrams off the Sargent website. We'll ask them to send you one, and it's a good idea to follow those. But things like the 12 volt socket, then you can decide where you want to plug that in. There's certain areas, like for the light socket, which is down there, this actually has a switch attached to it, the light socket, as well as the aux input as well, so that you can actually switch this from the front panel here. Perhaps when you go into bed you want to make sure everything that's all turned off. Same with the water pump one. So here's the back of our power management unit, just to show you what it looks like. So across here is where our mains plug sockets would plug into. Now there's actually an option to put 6 mains plug sockets here in total, even though there's just what it looks like 3 terminals. You can actually put 2 lots of mains plug sockets in each one. And there's also our grounding point here, so we're going to ground this out onto the chassis of the van at some point. Now I'll try and zoom in on the 12 volt sockets for you. There's a bunch of different lettering across here, and across there we have all of our grounds. So each 12 volt appliance is of course going to have a positive and a negative cable, so we're going to put the positive into whichever terminal, whether it's the lights or the aux, etc. And then we'll put the black one into one of the ground terminals along this side, and it's simply a case of just threading it through. So I'll try and put this one in to give you an example. So you just thread it up through this terminal here, and then screw it down with a flathead screwdriver. That'll be nice and tight. Great, and like I said, with the black wire we need to feed that one into one of the grounding terminals. Spelled GND on here, and then again screw that down. It doesn't matter which ground terminal you put it into, I'm just putting it into the furthest one at the moment because I know I've got plenty of reach with this cable. And then we have it. That's basically wired in now, our 12 volt socket. So you can go ahead and do that with all your 12 volt appliances. Just remember again that on the lights and the aux you have a switch at the front, so if you wanted to be able to switch off your lights and perhaps one other appliance, make sure you put that in the light and the aux terminals so you can use that switch. Same as well with the pump, if you want to use that pump switch that's on the front of the panel. Don't forget split is for the split charge relay, and EMC is to isolate those appliances and terminals, I believe 6, 7 and 8, whilst the vehicle's in transit. And you also have a permanent out and a fridge out and a fridge in. If you need to hook up a fridge, it's good to put them in there because it will give the fridge a constant source of power. You obviously don't want those being isolated or switched off while the vehicle's in transit because all your food's going to go warm. So yeah, just go ahead and hook it up. So below your 12 volt terminals is a block of 3 terminals, and they deal with your vehicle battery on your far left under VB. LB is in the middle there, and you've also got a ground, which you can see there. So you need to run a red wire from the positive on your vehicle battery into VB, and positive from the leisure battery into LB, and obviously we're going to take a ground out from the back of our power management unit there in that last terminal and ground that out on the chassis. For the earthing point I would use probably a 4mm cable. I'll also just point out quickly as well that for all of these connections into the terminals, all you need to do is simply strip off about 1 centimetre of the insulation on each wire. There is no need to actually crimp any terminals on here except for this one grounding point. So we're going to put a little ring terminal on the end like that. So a couple of other things then you're going to want to do once everything's been wired into your power management unit. You want to tidy up the cables as much as you can. So with my split charge relay system, they had these little sticky pads that you could feed these cable ties through. So they're quite handy for just tidying up these cables a little bit. You're also going to want to make sure that the wall inside your power management unit is partitioned so that nothing's going to come through and damage any of the wiring. You're also going to want to go ahead and attach your power management unit to whatever piece of furniture it's going into. You want to take out these little black stops. There's 4, 1 in each corner, and then just put some screws through, some flathead screws. And also one other thing before we go ahead and put the leisure battery itself into place, I'm actually blocking it in here so there's less room for it to move around. I'm also going to add a retaining strap. So once you've wired everything in, you just want to go and check that the fuses that are in place for each terminal are the correct size fuse for the wiring for your electrical appliance. The only one that I'm actually going to have to change is this 5 amp fuse here that is going towards my 12 volt socket for the cool box. So I'm going to change that out. I'm just going to wriggle that out. So for the retaining strap for the battery then, you can see there's 2 brackets here. Ideally you want to put these into the floor because that's going to be your most solid base to actually screw into in the event that the battery did go flying somewhere. But there's just a couple of screws either side on the brackets, and then you will also feed one of these through, and that will go over your battery to help hold it in place. But you can by all means use something else, just as long as it's nice and secure. Right, time for the moment of truth. Let's see if this works. So we first of all want to check everything is in the O position, that is the off position. We've got a few different switches. So we've got ones here for the water pump, and I actually haven't got a water pump on board on my van, but you could easily wire yours up to do so. This is actually for my 12 volt socket for the fridge, and we've got a lights aux input here, so this will isolate my lights if I need to. This is a general battery selecting switch, so we can either select to draw power from the leisure battery or the vehicle battery, or in the middle there it's just in its off position, so that's a 3-way switch there. And this one on the very end controls the displays, whether we have our display on or not. The battery charger switch will allow us to charge the battery whilst the vehicle is hooked up at campsites or we're on the move and the split charge relay is doing its thing. So you want to make sure that is in the off position when you are hooking up, and then once you've hooked up the cable you can then put it into the on position at the bottom there. This reverse polarity switch will tell you if there's a bit of a fault in your hookup cable, or perhaps with the power on the campsite. So if that comes on, you need to check that out. You can go ahead, if you want to plug in your mains inlet, you can switch that into the on position. Here you've got your circuit breakers. This is for your 230 volt, so your mains inlets gear, and this is for your fuses. But however you set this up, you want to go ahead and switch it all on. Just check that it is, of course, all working. So we're going to press the top button there to switch to our leisure battery. I'm going to turn the display on. And as you can see, we're getting a reading here from the leisure battery of 12.6 volts. Now if I go to the middle and to the opposition and to the vehicle battery, we're getting 12.5 volts from the vehicle battery. So they're both doing alright. But we want our leisure battery anyway. And then we want to switch the lights on. And we want to switch our water pump, which is my 12 volt socket. And then we can go ahead and check the actual work. So as you can see, when I switch the lights on, we get the little blue light, which is cool. That means that's working. And these are touch sensitive, so I haven't put in a switch. There's a switch on the light itself. I literally just touch them like that. And the cool thing about these is they have a dimming feature as well. So if you hold your finger on it for a while, as you can see, it will switch lower down. So check things like your fridge as well. Remember that your fridge will most likely be able to isolate itself, so it won't come on automatically. You'll probably have to actually switch it on the fridge itself. As you can see, we've got a core box in this one, and it's all working. And if you have any USB sockets like we do, you can go ahead and lift that up. You should see a little blue light there working. You could plug something in like your phone, see if it works. Happy days. For my mains plug, as I don't have an inverter on board, I can only use it whilst I'm at a campsite and I'm hooked up, or hooked up to a mains plug at someone's home. So basically what I'm going to need to do is get a extension lead, one of those 3-pin extension leads that you would use to hook up at a campsite, and you can get an adapter that you can put on the end of it, and it will give you a mains plug that you can then go and plug into a mains plug at home, and then I can go ahead and check that these 230 volt mains sockets work. So although we haven't installed a solar panel on this camper, I'm going to go ahead and just talk a little bit about it. We did install one on our last camper van, and I'd highly recommend doing it, especially if you're doing lots of wild camping and you want to be more sort of self-sustainable. We've just had a single 250 watt solar panel, and it was made by Photonic Universe, which I'd highly recommend checking out. I think they're a German company, but they were really helpful on the phones with everything, and the panel worked great. So it's just simply a case of first mounting some legs to your solar panel. You can also get these like semi-flexible ones as well, but you can mount these solar panels either to a roof rack, or you could mount them onto the legs that they will most probably come with. And to do that, you'll literally just screw the legs onto the solar panel itself, and then you can mount that onto the roof of your van either using some Sikaflex, some sort of adhesive like this. Anyway, this is Sikaflex 521 UV that we use, and it's weather resistant, UV resistant, and it's a really strong adhesive. They say that is strong enough on its own to adhere the solar panel to the roof of your van, but I did actually put a few screws in as well on each of the 6 legs, and then I put some more Sikaflex around those just to make sure they're weather tight. Then there's literally just a positive and a negative cable. You'll see it, there'll be some clips on the end of them. You should have some cables provided with the whole package that will then clip into that positive and negative coming off the solar panel. And you'll basically want to create a couple of holes in your van. You should get a little box that the positive and negative cable can then feed through, and you'll be able to tighten a nut on those so that it will close up around the cable and make it weather tight, and then they will then feed down into your van. So you'll have to create 2 holes in the roof of your van using a metal drill bit, and then feed those down into there, and then you'll use some Sikaflex to hold that little sort of junction box into place and make it weather tight. So once you've got your 2 holes then, that's going to allow your positive and negative cable to come through the roof, you're going to want to feed that down across the wall. So you're going to need to install your solar panel fairly early on in your build before you start putting the walls in. So during the first fixing, you're going to want to know whereabouts you want your charge controller to be pretty early on, because you're going to get to a certain point, and then that's where you know your positive and negative cable are then going to feed into the charge controller. Now the charge controller will basically tell you how the solar panel is doing. It will probably display how the leisure battery is doing. It will tell you how much voltage you're getting in off the solar panel, It's basically a great way of just seeing what sort of power you're getting in through. Now there's two different types of charge controllers, and there's one more efficient than the other, but I believe that one is about 90% efficient at turning the energy from the solar panel into usable energy for your battery, rather than the other slightly cheaper version, which I think was more like 75–80% efficient. So it's definitely worth paying that little bit more to get more energy in your leisure battery. It's basically just a case then, if I remember rightly, of just taking a positive and negative cable then from the charge controller, and that will feed onto your leisure battery. And as you remember, if I show you here quickly, we have these battery posts, and we'll basically want to just put some ring terminals or some lugs on the end of our cables, just like we have done here, and then you can just literally bolt them down on top of these existing cables that are already on here. So on our battery posts we needed an 8mm hole, so if you need to buy any ring terminals or lugs, make sure it's got an 8mm hole on it. You'll also need to install an isolation switch as well on your solar panel. This will all be in the instructions, and so it will be pretty straightforward to do, but the isolation switch will obviously make sure that you can definitely switch on and off, because it is just going to be hooked up straight to the battery. So another thing I want to briefly talk about are inverters and what they do exactly. Now in this camper we don't have an inverter, we can only run our mains plug sockets whilst we're at a campsite. But what an inverter will do is it will take your 12 volt power that you're getting from your leisure battery, and it will bump it right up to 230 volts so that you can use your mains plug sockets without being hooked up at a campsite. So this is great if it's really essential for you to have a mains plug socket whilst you're wild camping. Now I would highly recommend, wherever possible, using just the 12 volt appliances and not having to use an inverter. The reason being is that they consume a lot of energy. If you can imagine taking 12 volts and bumping it to 230 volts, it's going to require a hell of a lot of power to get it up there. So regardless of actually how much power the mains appliance is consuming, the inverter itself is actually going to consume an awful lot of power just converting it from 12 volts to 230 volts. So for instance, if you say, like I have a MacBook Pro here that I need a mains plug socket to charge with, you can actually get a 12 volt adapter to charge a MacBook Pro with. So I would actually invest in getting one of those instead of using the inverter. That way I'm going to save the inverter sucking tons of power off my battery and limiting what I can do whilst we're wild camping. Again, also if you've got like a camera or something like that, or your phone, you can install some USB sockets and you could use those to charge those with instead of having a mains plug. Right, so it's absolutely essential then that you have a mains plug socket whilst you're wild camping on the road, etc. Then by all means install an inverter. Now they come in a range of different wattages, and to work out which wattage you need in your camper van, you need to take the electrical appliance that consumes the most amount of power and find out what its startup current is. So for example, if we had a microwave in here, that would be rated at 800 watts. The startup current for that would probably be about 1600 watts, so double what the actual rating of the microwave is. So therefore we would have to get an inverter that could handle 1600 watts of power. So if you can do without, things like that which use up a lot of juice, like microwaves, hair dryers, etc., then you could save yourself a little bit of money and you could get a smaller inverter. For the mains plug on my laptop, it's rated at about 60 watts I believe, so I could get a 150 watt inverter and that would do it just fine, and it will save me some money, and it's also going to use up a lot less power as well. Now, there are a couple of different inverters that you can get, and they'll differ in their waveform. So you can get a pure sine wave inverter, which is the best one that you can get, and you can get what's normally known as sort of a modified sine wave inverter. It has a few different names, that second one, but basically the pure sine wave inverter will give a really, really smooth waveform, so it will give a really smooth output of electricity to your mains plug sockets whilst you're not hooked up at a campsite. And the modified sine wave inverter will give sort of a square waveform, and it can actually cause some things like laptops to crash and stuff, and it's not quite as good as a pure sine wave inverter. The benefits though of having a modified sine wave inverter is that it's a hell of a lot cheaper than a pure sine wave inverter. So you basically just need to balance it up and work out which one works best for you. Thanks for stopping by everybody. Please like and subscribe and check out our other content on all things camper. As I mentioned before, I've just recorded my first album and need all the help I can get. So I'll leave you with an album preview for now and a link in the description if you'd like to pick up a copy.
She does all that she can. Fears anymore. Time, I'm heading west, yeah, till I cross that line. $6 short, but my soul is clean. I need one more dime. The fruit machine swirling waves on me. Yeah. You put their cold and harsh demeanor. It'll soon come back around. So don't let the bastards get you down. Keep on running through the heat, where you gotta keep on living.